This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Today we'll identify whether functions are continuous based on their graphs. Let's learn how. A function is continuous if its graph has no breaks or discontinuities. In other words, you can draw the graph of a continuous function without lifting your pencil. Some examples of discontinuities that would force you to lift your pencil are holes, jumps, and vertical asymptotes. If a function has any of these discontinuities, then it is not a continuous function. Let's see some examples. Is the function in the graph continuous? Let's imagine drawing it out with a pencil. As we trace the path of the function, we never have to lift our pencil from the page. There are no breaks, and so the function is continuous. Let's take a look at another graph. Is this function continuous? Using our imaginary pencil, we can smoothly trace the function until we get to x equals 7. At this point, we must lift up our pencil and jump from y equals 2 to y equals -1 in order to finish tracing the function. Because of that jump at x equals 7, this function is not continuous. Nice job! How would you identify whether this function is continuous or not? If you start tracing the curve, you encounter a hole when x equals -6. This hole means that the function does not exist at that point, and so you cannot cross it with your pencil. Instead, you must jump up to the point -6, 8, where the function is defined, before jumping back down and continuing your tracing. Because of the hole at x equals -6, h of x is not continuous. Let's continue along. Is the function p of x continuous? When we look at the graph, we cannot see any discontinuities such as any holes, jumps, or vertical asymptotes. Because there are no breaks, p of x is a continuous function. Sure enough, if we used our pencil to trace it out, we can continuously trace the entire function without lifting it off the page. You're doing great. Let's do one more example together. Do you think our final function is continuous or not? In the graph, we can see two breaks. The first one is at x equals -5, where there is a jump. Based on this discontinuity alone, we can say that g of x is not continuous, since any discontinuity means the function is not a continuous function. But to bolster our claim, we can also see a second break at x equals 4. Although the function is defined when x equals 4, as the function approaches 4 from the right, it increases towards infinity, approaching a vertical asymptote. So g of x is definitely not continuous. Great work today! Good luck as you continue identifying continuous functions.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.